Hello, this is Caleb Marciano, and this tutorial on how to use AlbaBuild.nvim. So in order to use AlbaBuild.nvim, you must first open nvim. And in order to use it, you must specify our build commands on disk. So to do so, we make a .albabc.json. And then we're going to go ahead and we're going to copy the example from the readme.md. We're going to go over the parameters used in the example, but there's more parameters we're not going to talk about here. You should read the readme.md to see those. The structure is as follows. It is a JSON object with two different objects specified in the root, envars and build commands. So in envars, environment variables, you get to specify individual things like, the different variables used in bash commands, your shell CMDs. And these are merged with your default environmental variables as specified by sh:\c. Build commands is an array or a object with each key being a string of a number. In this case, it's an array, where the first object is equal to 1 and the second object is equal to 2. So we're going to edit this and change the CWD to dot to represent dot. These first three are mandatory. These two, and among other optional variables, are not mandatory. I think it's worth noting that the CWD is relative to the directory that the .albabc is in, specifically. We're going to edit the CWD to be just dot to represent the current directory, and we're going to do it down here as well. We're going to change this to run Python. And we're going to modify this to say python3 u example.py. It's important to specify u here because by default Python buffers its std out, and that has issues with error handling. This is not an issue for most things. Additionally, because there might be errors where Python might run for too long, I'm going to specify a timeout, 80 seconds. That way, if it runs for 80 seconds, it'll automatically end. Additionally, I'm going to add a print ongoing to this, and it's going to be set to true. So it auto opens and it prints ongoing, and print result is going to be gone. So in the example, we're going to be making a little graph, a very simple graph, to show the change in balance of our Bitcoin wallet over time. And we're going to be using this command to generate our Bitcoin. And this is going to be bound to 2, and this is going to be bound to 1. Very simple. In order to do this, we're going to import http.client. Import base64, import JSON, import time, and import matplotlib.pyplot as plt. Okay. Simply, we're going to set the username to be user1, and the password to be password. And then we're going to v-split because I don't remember the port, and we're going to go over to the RPC port and say port equals this. No. And then we're going to make the authorization sets. And then we're going to do b64 data equals data. And then we're going to do a free flow test by doing xp1. And we're going to see that we have an error importing http.client. So what did I do wrong? There's a typo. And then we're going to try and run it again. And there's also a mistake here. And then next we're going to be making our HTTP client. So in order to make our HTTP client, we need to make a new HTTP client connection. We're gonna run to see how this goes. Okay, that's fine. And then we're gonna do a little bit of plagiarism, self-plagiarism, real quick. So we're just gonna do a bit of self-plagiarism real quick here, and here's my BTC repo where I already made a HTTP client for this. So we're just gonna do copy the code over here. So base request equals JSON RPC equals string 1.0 and because we're only going to be requesting a singular endpoint, we're going to be doing our method as equal to get balances. Alright. We're going to be doing con.request post slash and then we do con dot request post and then the URL, that's slash, and that would be json.dump, and that's going to be the base request, and our headers are going to be authorization, and it's going to be our credentials. Alright, that's about right. We're going to do a little bit of a test here. Sorry, json.dumps. And then we're going to do a con.getResponse. And this gave us the correct response. So we're then going to do a little bit of parsing for this. And then we're going to make a list of the types of balances. So we're going to do JSON response equal JSON.loads response. We're going to print it just in case. Also, I'm going to turn print ongoing off because it's not good for this. So now we're going to do I'm going to do trusted, untrusted pending, and immature. We're going to do values equal in an array for response, JSON response mine k for, I forgot the quote here, for k in types, and then we're going to print values. And then we're going to do a sum on this to get the total amount of Bitcoin. Okay, so 321. And now we're going to put this in a while loop. And we're going to add a x equals and a y equals. And then we're going to sometimes and then we're gonna be doing a y dot append total. Boom. Neato. And then we're going to be and we're gonna do current time equals time dot time, and we're gonna make this an integer, and we're gonna do a x dot append current time. And lastly, we're gonna add a option to break out of this loop. We're gonna do c equals 0, and if c equals 40, break, and then c plus plus, or plus equals 1. 9. We're not in C. And we're going to print x just to do our test. Okay, so that works fine. And lastly, we're going to do a plt.plot x, y, and plt.show. I'm not sure what's happening here. We're going to do a print y. Oh, print x, sorry. So, and we're going to do a time.sleep1. So now this will take 40 seconds to complete. So, we're going to do our run. Or wait, we're actually going to kill it. We don't want to do that yet. We want to do a little print here. Print C. And then we're going to turn on print ongoing. Hey, so no code was actually changed, but I had an issue to recording, so you can actually see the pop-up. So I'm just going to re-recording it now, a few hours later. So I started the Python application, and now I'm going to be doing xb2, generate some new Bitcoin. I'm gonna keep doing that a few times. Pay attention to the number in the corner. It should correlate with, you know, me raising it. Let's check. So we're going to time one for 35 specifically, so you'll see it in the application. There we go. Let's see what happens. So here's the output. And obviously after T35, you can see a distinct increase, and you can see me waiting for it, and you can see all this. So this was entirely started with just, you know, key binds, because if you'll see, we have our key binds here. So because we had Python 3 bound to our first keybind here, and we had our Bitcoin generator on this second keybind, we could just interact with it. An example of how to use it. In a test scenario, this could be somewhat useful.